Hello everybody, thanks for coming and thanks for being interested on the Solcer House. Unfortunately today we couldn't attend to the conference, but we will be happy to explain the Solcer House to you, and if there's any questions after my presentation, feel free to email us and we'll try to help and answer your emails. So, today I'm presenting the Solcer House. It's an energy positive, low carbon, low cost house. My name is Ester Coma. I am the architect of this house, and I've been working for the Welsh School of Architecture and Cardiff University doing this project. The aims of the project were mainly four. The first one was to design and build a house that could be affordable and integrate low carbon technologies into the building design. So we didn't want to add PV panels or other type of energy systems as a bolt-on approach. We wanted to make sure that these were integrated. The second aim is that we want to optimize the whole building energy system. So rather than to go for a components approach, we wanted to look at the whole system performance. Therefore, we have aimed to reduce the energy demand by using LED lighting and high energy efficient appliances. Also, we have integrated renewable energy supply with photovoltaic panels and transparent solar collectors. Finally, we have integrated storage for both thermal energy and electrical energy. The third aim was that all the components of the building needed to be supplied as far as possible from Welsh manufacturers. This way we were not only increasing the economy and improving this economy in Wales, also we were demonstrating that the Welsh construction sector and the technology sector could be producing this type of houses, and also we wanted to generate jobs as well and engage with the local supply chain. Also, we needed to make sure that all these components were affordable and replicable to make sure we could start building these houses everywhere in Wales. The last aim is that although we are trying to do all these new things and innovative approach, we need to make sure that we guarantee the comfort for the occupants of the house. So regarding the project partners, our main funding body was WEFO, and it was part of the LCRI Convergence Energy Program launched in September 2009. The project leader was the Welsh School of Architecture, and we work in collaboration of a big team. Part of the team was Professor Phil Jones, the PI of the project, Dr. George Patterson, and myself, among other people. For the design of the house, we propose a footprint of 6 by 10 meters. Basically, we have located the living room area into the south-facing facade. The kitchen is in the north, and also we have the shower room or the bathroom areas in the center of the building, so we can have a core wall with all the systems in there. In terms of bedrooms, we have a double bedroom facing the north and then 2 single bedrooms facing the south. It's all been designed so we can comply with the performance as well. We were looking at daylight analysis just to make sure that windows and light was coming through the rooms with enough daylight factors and at the right rates. So we did some daylight analysis. Also, we did some thermal comfort analysis to make sure that we didn't have any overheating problem. As you can see in this table, there is less than 1% of the time with the risk of overheating, which is below the benchmark. That means that our house is, in terms of thermal, it's approved and it can go further for the BREEAM accreditation. We have designed the house for BREEAM, as I said, so we were targeting excellent rating in order to comply with the WEFO funding requirements. Also, we were complying with all the building regs, lifetime homes, development quality requirements, so it's all ready for social housing use. And also we looked at the considered constructors scheme and the NISEIC electric certificates. So when we were doing the detail stage, we needed to make sure that what we wanted to design was possible to be built. So we looked at all the supply chain, local companies, to make sure that we could engage with them and that they were happy and aiming to collaborate with us. So as you can see, there are more than 10 suppliers and manufacturers. We had a huge supply chain, and it was a really learning curve and a really good experience for all of us. In terms of the systems, we have integrated power and thermal. With the green letters, you can see the power side. So we have the supply coming from the photovoltaic panels. Then we have a storage with the 6.9 kilowatt hour battery. And finally, we have demand with the low energy demand, thanks to the LED lighting and the A+ devices and appliances. In terms of thermal, we have the transparent solar collector into the south-facing area. We then have the storage integrated into the heating system. It's a combi unit and it has a hot water tank in there. And then we also have the demand, which has been reduced as much as possible thanks to the low U values on the walls with the SIPS panels and the double glazing with low emissivity as well. So as you can see, we have tried to integrate all the systems and made sure that they were part of the design of the building rather than just added systems that you can add later on. It's all working together. So the construction stage was the most challenging one. We started the works on site on October. We started preparing the ground to make sure it was all ready when everything, all the materials, the SIPS panels were coming in. For the foundations, we basically made sure that there was insulation at this level here. You can see it pointed with the mouse. This was to stop any heat loss, any thermal breach below the SIPS panel. And also we have used low carbon cement from Kenin to build our foundations. Then the SIPS panels came in. They came all in one lorry and they were installed in 3 weeks time. So it was in middle of winter. It was a big challenge. And it was really good because you don't need a lot of energy on site, you don't need any water, it's very straightforward, it all comes manufactured from the site, and it's quite easy, and well, not easy, but it's much better than working on site only, producing a timber frame, we think. Also the U values are 0.14, which is very good, and it helps us to keep a better airtightness rate for the building. When we had all the frame erected, then we installed the roof in order to make sure that the house was waterproof. The PV roof is manufactured by GB Sol. As you can see, these panels are also kind of transparent, so you have spaces between cells and the light and the sun goes through these spaces. And it was all erected in 1.5 days, so it's a really straightforward system, and it not only gives us the energy for the appliances, but also it protects us from the weather. So it's a PV and also is the roof of the house. Also we integrated the TSC system on the south facade, as I said before. This is the way that the TSC system works. Basically you have a lot of perforations into the main cladding, and then the air goes through these perforations, it stays in this cavity here, and it's heated by the sun. So when it's sunny, we have estimated, and we are now monitoring the temperature rise from the air, but it's roughly about 10-15 degrees, which is really good because instead of bringing cold air from outside to the heat pump, you are bringing preheated air, which means that you have a much better performance and a higher COP for the heat pump. So we are driving this air inside the house, and then we are, in case it's not heated enough, we are heating it more with the heat pump, and then we provide all the heating loads for the house through the air. No, we don't have any radiators and we don't have any underfloor heating, so it's all by the means of air. Also, we installed an external insulated render to make sure that we didn't have any thermal breach between the SIPS panels or where the joists are. So it was a system installed by Joiner Group, and it's a Parex system. It's insulated and also it doesn't have any cavity. Also the electric and battery system was very challenging. We installed a lot of circuits to make sure that we could monitor all the appliances and lighting separately. This is in terms of research, it's nothing to do about the house. We just wanted to learn from it and to make sure that we could get as much data as we could. In terms of innovation, we installed this battery system that you can see on the right side. Basically, it's a Victron system, and it stores the energy that we don't use during the day. Or when there is an excess of energy being produced by the PV panels, then we store this energy here. It allows us to use this energy during the night, and we estimate that together with the photovoltaic panels and the batteries, we can achieve 70% of autonomy for the energy consumption. Also, you need to bear in mind that the house is off-grid in terms of gas, so we only have electricity consumption. So these batteries are one of the big points and one of the big more important things of the house. And finally, we have this heating and ventilation system. It's called Combi 185. It's from Genvex. And basically what it does, it has a heat recovery ventilation system. Also, it has the heat pump, just in case there's not enough heat from the heat recovery. And finally, it has a hot water tank, which allows to store the heat into water when the heat is not needed for the space heating. So this is a really new type of system, and we are now testing it and making sure that it's working, and it's working as the manufacturer of the unit claims it is. So far it's very good, and we are really happy with it. Just some photos of the internal finishes to have a final look of the inside of the house. Well, as you can see here, the house is now built, it's finished. The aspect of it, it's pretty good. We are very happy with it. It's all integrated. You can see how the photovoltaic panels have been integrated into the same plane of the roof. Also, the TSE is fully integrated into the facade, and it's 17 square meter TSE. It was quite a big challenge to install such a big area in a facade. And then also you can see we have weather station to monitor all the weather data and to use for our further research. In terms of performance, we are monitoring everything. You can see how we installed some of the sensors. This is on the bottom left corner. You can see a sensor being installed into the TSE area to monitor surface temperatures. Also, we have installed flow sensors. We are monitoring all the data in a data logger to make sure we collect all this data in the university. So these are things that we will use to monitor and to optimize the systems and to make sure that we are guaranteeing comfort and quality to the house. In terms of cost, we estimate that the cost of the house can be around £1,000 per square meter. Our first house was not discussed, of course, because it was the first one. We had a lot of products that were not installed before by the suppliers or the installers. But we estimate, and after discussing with them, we estimate that we can reach this £1,000 per square meter, which is it's within the benchmark of £800 to £1,000 for social housing. In terms of embodied CO2, we have calculated the embodied CO2 of the house materials, and this is roughly 340, which is below the standard of 500. Just to point out that the solar PV is the highest one, the one with more embodied energy, but here you have to take into account that in the future the solar PV will allow us to balance the CO2 emissions, because we will get a lot of energy from the grid and it's producing renewable energy, so it's kind of a balance curve. And well, just to point out that we have won some awards, Cardiff Uni, Constructing Excellence Wales, and today we couldn't attend to this conference because yesterday we were in the Canal Cambry Awards. We have been shortlisted for the project of the year, and well, right now I don't have the results, but I hope we can get that one as well. Well, thank you very much, and if there is any question, I have put the email address in here, so please feel free to email us and we will happily answer any question, and I wish you all the best and enjoy the rest of your conference. Thank you.